people walking on planks and boards and things are very common when you're dealing with these statics problems here. So although I'm not going to solve these problems because another video sort of tells you how these things work, I just wanted to point a couple of things out about the way some of these problems go. Here's a problem here where you can see a board sitting on two supports like this. And what happens is there's a person on here that is a distance x, maybe from this rightward support here. So what the problem may or may not ask, or may in this case here, is just how far can the person walk this direction here before the board tips. So a problem like this is about the board tipping. And you can imagine then that as the board tips here, this support will be here and this support will be here, but you'll just start to see this big angle develop like this. The board's going to start to lift off that left support, and the person will be standing here, and that's what we mean by tipping. Okay? The other problem, so I'll say a few things about this, and the other problem I wanted to look at was problems like this, like a diving board at a pool like this. I just wanted to point out something like, say, there was a big bunch of water down here below the person, so they're on the diving board about to jump off. What sort of forces are involved with that here? And we'll take a look at that, where these things are all tied together, just to make sure we get the direction forces right. Okay, so first things first, just a couple discussion points here. What you do in a problem like the one where the person is walking on the plank here and we want to know about tipping is you start the usual way, and there's another video that discusses how this sort of works here. There'll definitely be an F1 right here and definitely be an F2 right here. And of course you'll have the usual things. You'll have the weight of the beam down and the weight of the person down like that. So the problem starts just like one solved in another video, and you set everything up the same way. But now what is it about this tipping? How do you know when the board tips? Well, if you look very carefully at the problem here, tipping occurs where this board here leaves this leftmost support. It's going to leave the leftmost support. So I would encourage you, when you analyze your torques, to go ahead and put the axis of rotation right here, right above that rightmost support. That's a very natural position there, because as it tips, you can imagine it rotating about that red dot right there. But the issue is what happens right in here. Right in here where the board starts to leave the pivot. And what happens right in there is F1 becomes 0. In other words, you do not need that leftmost support anymore when that tipping happens. So what you do, though, is you just set up all your equations, and at some point in your equations, just set F1 equals to 0, and this is the math for tipping. In other words, you're telling your equations in this problem here that, yeah, hey, the board is tipping now, and whatever solutions you might get or whatever numbers pop out when F1 is equal to 0 refers to the tipping case. So that's all I wanted to say about that, and just I hope you can visualize that when it tips, the board leaves the support, and the force is no longer needed, or it drops abruptly to 0. It'll start getting, as a person walks this way, yes, this support force, this required up here, will get smaller and smaller and smaller until it eventually becomes 0, but that's the point where the board leaves the surface, and it's no longer in contact with the support. Okay? So that's about it on that one. Just a few comments there. And on this one right here, got erased just a tad bit here. This is a diving board case here where the same sort of thing can happen. The person can definitely be some distance from these pivots, but these things are now tied together. We don't allow tipping to happen, so maybe they're bolted. And I don't know what the problem is asking. There could be a variety of things, maybe what the support forces are. But the goal is sort of what I want to tell you now is just how to make sure you get the directions right on the forces here. So if a person is standing here on the end of the diving board, they definitely have their weight down. There's definitely an mg down. And wherever the center of the board is, I guess on this drawing I'll sort of put it here, there's definitely going to be a big mg down due to the board right there. Now what do you do about the supports? Are they both up, both down, or what? Well, just try to visualize a tad bit here, that as a person standing on the plank here with all these downwards weights, something has to pull up on it like that, or push up on it, and it's definitely going to be this one right here. So I'm just going to declare that this force here, F1, is definitely going to be up like that to sustain, well, the weight of the board. Now what's going to happen is if this thing isn't going to tip because the person's all the way over here on the end, I'm going to sort of declare that this force over here is probably going to be down. In other words, this support sort of has to pull down on the diving board like that to hold this end from flying up like that. Just the opposite to this problem right here, but nonetheless very similar. So I think this will definitely be down, this will definitely be up. And that's sort of intuitive of what we might think, and I'm pretty sure that'll come out to be correct. But also just remember that if you did not know this, say you even put these wrong forces in here, what you'll get when you do your algebra, say you got the directions wrong, you just get that F2, say, came out to be a negative number, or maybe F1 here came out to be a negative number, or something like that. And that would just mean if you got negatives that you need to flip your orientation of the forces you guessed wrong in your drawing, because it may be impossible to tell. But anyway, just a few tips there, a little bit of insight into people on planks, which is a very popular concept in statics problems.